everyone. In this video we are going to build our simplest possible AI model using the linear regression, the algorithm which we have thoroughly run in the past two videos. We will see what is the code implementation with an example. We will be using a data set. Now let us just start quickly. So by the end of this video you will be able to have a complete understanding of the linear regression along with the code and self-build a simple AI/ML model with linear regression. You can try it out in your own computer too. So first we need to import the necessary libraries. So these must please ensure that these are all installed in your PC. These are all libraries. If it is not installed, you can do just simply, suppose cbond is not installed, you can write pip install cbond. It will be automatically installed, and if pip is also not installed, then you can go to the description. There is the link of how you can install pip in your computer and make it ready to use using command prompt. So you can go watch those and download all those libraries in your PC. So after downloading, you have to just import it as many times you can import. And I have, you see here, I have an Excel format. The format was Excel, but I saved it with .csv, so it is price.csv. So this is our raw data set, price.csv, which we have stored in the same folder as this regression and descent. So this is our output. So we do price equal to pd.read_csv. This price.csv is present here. It extracts it from here, and this is our raw data set. So you can see there are 3 columns and a number of rows are also there. It extends more than 13. It is basically 40 rows, but real life data will be more, right? So more the data you will feed, the more your machine learning algorithm will become clever and much more accurate it will predict. So we can simply drop the first column. So access equal to 1, in place equals to true. In place means at once it will get deleted, otherwise it saves a copy. If you don't give this in place equal to true, by default it is in place equal to false, and it will save a copy. It won't change your original database, but at once we are trying to change our original database, and this access equal to 1, this is for the column access. So this was our SB cbond.heatmap price.isnull. So this is an important thing in the Titanic data set. In the previous video you have understood, last video, I made you understand that this pink color indicates that there are no null values, and so we are good to go. So we can just have a check of this here. Now we are extracting our x and y values. Price.ilog, all the rows, I want all the rows and the first column. Y, in y I want all the rows and the second column. So we'll see what our x is. Our x will be basically the area, right, and y will be the price. So from sklearn, now we import model selection. Why we do this? To implement train test split, right? It's quite simple. X train x test, y train y test, model selection dot train test split x y x test size equals to 0.2. So by default this test size is 25%. I have taken here 20% for convenience. So this test, you can see it is a series panda code, right? So from now this is our algorithm. So what all stuffs we have learned in our previous videos, like those of implementing the partial derivative and all those things is handled automatically by the computer in this inbuilt sklearn model. So object equals to linear regression xtrain.shape. So you can see it. So it is not a 2D array, so we will see that what to do. If we try to fit our data, right, we use fit function, object.fit xtrain ytrain. So you see this VS code is so useful. It tells you what you have to, it not only tells you the error, it will also tell you what do you have to do to correct your error. So it's really useful. So first I've shown you this error most of the beginners face, so I just showed that this error you also might encounter. So what you need to do to change, reshape your data either using array shape minus 1 comma 1 if your data has a single feature, or array dot reshape this if it got a single sample. So earlier extend dot shape only contained 32 comma, there was no one. So the thing we need to do is to reshape minus 1 comma 1 np dot array extend dot reshape minus 1 comma 1, so that it converts into a 2D array. So we need 2D array. Why? Can you guess why? What is the reason of being a 2D array in X train but not in Y train? But because we have multiple features, we may have multiple. Here we are having one feature that is different. We are having only the price, but it may be possible that near some shopping mall or near some marketplace the price of the house is more, so that may be a determining factor. So those all features we may also add here, right? What is the distance from a market, so that the price may be proportional to distance also, like inversely proportional. The farther away from the distance from the market, the lower is the price, you can say like that. So uh, that those also things may be determining factors. So those, if we add those, our dimension of the list will change. So extend by default in the scalar always assumes that you have a 2D array. So now we can do object.fit extend y train. Earlier we got an error, but this time there is no error. Now we can see what is our intercept of the line, y equals to mx plus c. This is our intercept of the line, and using using this formula which we derived in the previous video, this formula will be used by the computer to calculate m. We just need to do object.intercept and object.coefficient. So that's all, right? And now we can plot. So if you see, if I try to plot it like this, np.a range go from 1 to 10 with a step of 0.1. If we do this, y equals to mx plus c, we are basically taking 10 data points 1 to 10 with a step of 0.1. Now we are plotting x comma y, and then we are scattering all the points x test y test. So we will get two graphs, basically one this. So we see that this is not completely fitted, right? The data points are spread and this, so we can reshape it. So you can see the approximate, it starts from about from just after 1250, it's the x-axis, and it goes till 2000, right? So I have done 1250 to 2000, 0.1, y equals to mx plus c, plt dot plot, plt dot scatter. Now along with the line we will also get this. Earlier also we had got the line, but the line was so small we couldn't see it, right? The line was present here, just here. The line I have taken from one, I have taken from 0 to 10, right? The line was just present here, and all the points just, if I can take you to the next previous slide, if you see this, see this is the line, so small. I have taken from 1 to 10, but now I see that this is the part of our manipulation. This error is expected at first, right? So after this you can simply get it. So you see how much error is this, and you can also predict, you can start predicting using this. So our AI model is basically now ready. We can start predicting the score. And suppose I need to buy a flat with area of 2500 of whatever dimension, square feet or whatever, uh, this particular house will cost me this much amount of whatever currency that y value has. So if we just keep on changing, suppose our ML algorithm is now ready. So if we keep on feeding more and more data, our algorithm will become really means accurate. So yeah, if someone says that I want to buy a house whose area is 2505 or 2501, it exactly would predict according to this line. So our model is now ready. What is our score of the model? It is having, it's not 71.35, it is 75.87 accuracy. The using score, what does this score use? I told you this formula, it is known as the coefficient of determination. In my previous video I explained you, you can multiply with 100 to get the percentage. So this formula is used to calculate the score here. So in the next video we will see how to improve this score. Now we will go one step ahead of linear regression, of polynomial regression. we will go. And you must understand one thing: we don't want too much of accuracy. It depends in, see, ML model, it depends on our exact model. What is our model? For suppose we are building a driverless car, suppose, so that is also an ML algorithm. So there we want 100% accuracy. There we don't want even 1% chance of the our data is 1% also error we don't want, because that may affect lives of human beings, right? That may cause accidents and all. So there we want 100% accuracy. But everywhere above 90 also, if the accuracy goes, you should have a sense of suspicion in telling you that you are going somewhere wrong and you are just doing like overfitting the data, because you are, it may on the testing set, on the already known testing set or the already known training set may perform really bad, but some external tests data which when we will feed to the our ML algorithm, it will perform really bad. So we must take care. But 75 accuracy a bit low, you can say. We can increase it to 82, 83. So how we will do that? We can add more features and do that. We will see that in our next video. So